Very good evening, student, and all of you are welcome in CBSE Neet chemistry classes. From today, I am going to start CBSE Neet chemistry classes in which I will discuss about some of the very important concepts of organic chemistry which will be very helpful to solve the question based on those concepts. In today's session, we are going to talk about how to find out hybridization of the atoms present in a given organic molecule, and also how to find out the hybrid orbital as well as structure of the reaction intermediate. So now let's start the class. सबसे पहले यहाँ पर हम लोग हाइब्रिडाइजेशन फाइंड करेंगे। मान लो कोई ऑर्गेनिक मॉलिक्यूल दिया हुआ है, ये H2C डबल बॉन्ड CH सिंगल बॉन्ड CH3, it is simply propene. If there is a single bond between two carbon atoms, then its hybrid orbital will be sp3. If there is a double bond between the two carbon atoms, then each of the bonded atom acquire sp2 hybrid orbital. It simply means if there is a single bond between two carbon atoms, it will be sp3. In case of having double bond, it will be sp2, and in case of having triple bond, it will be sp. For example, HC triple bond CH. Here we can see that both the carbon atom bonded with the triple bond, so its hybrid orbital will be sp, and the remaining p orbital are unhybridized, which means do not take part in the hybridization and used to make pi bond. तो ये इस तरीके से हाइब्रिड ऑर्बिटल हम लोग आसानी से निकाल सकते हैं. नाउ वी आर ट्राइंग टू फाइंड आउट द हाइब्रिड ऑर्बिटल एज वेल एज द स्ट्रक्चर ऑफ द रिएक्शन इंटरमीडिएट. फर्स्ट रिएक्शन इंटरमीडिएट, फ्री रेडिकल. What we need to do, we have to count the sigma bond, which is known as bond pair, and also the lone pair or unsaid pair of electrons. So there are three single bond, so the number of sigma bond 3. There is no lone pair, so its hybrid orbital will be sp2. sp2 means trigonal planar. sp2 simply means trigonal planar, and bond angle of 120 degree. We can express this in this way: 3 sp2 hybrid orbital forming 3 sigma bond and 1 2pz orbital which do not take part in the hybridization contains the free electron. So the bond angle here you can see that it is 120 degree. Similarly, we can find out the hybrid orbital as well as the structure of carbocation. Here you can see that the number of single bonds are 3, which means sigma bond 3. There is no lone pair, so it will also have sp2, that is trigonal planar structure. Trigonal planar structure like this. As we have in the case of free radical, 3 sp2 hybrid orbital form 3 sigma bond, and there is a bond angle of 120 degree, and this orbital 2pz orbital written as empty, that is the vacant orbital, which will be further used to gain unshared pair of electron to complete the octet. यहाँ देख सकते हो कि जो कार्बन है उसके पास 6 इलेक्ट्रॉन है, लेस देन ऑक्टेट, एंड दैट्स व्हाई इट इज अनस्टेबल. तो ये जब किसी से 2 इलेक्ट्रॉन लेगा वो यही 2pz, दैट इज एम्प्टी 2pz ऑर्बिटल में वो इलेक्ट्रॉन कंटेन करेगा. एंड फॉर दिस रीजन, क्योंकि ये इलेक्ट्रॉन को ले रहा है, इलेक्ट्रॉन लविंग है, it is also known as electrophile, and all electrophiles are known as Lewis acid. तो ये कार्बोकेटाइन का भी हम लोगों ने किया. कार्बेनियन, when the carbon atom acquire negative charge with one unshared pair of electron, then it is said to be as Carbenian. Here we can see hybridization, bond pair plus lone pair. There are 3 sigma bond, so bond pair will be 3, and lone pair, 1 unshared pair of electron, 4, 3 plus 1, 4, sp3. sp3 hybrid orbital containing 1 lone pair of electron will have distorted tetrahedral structure, and the shape will be pyramidal. 3 sp3 hybrid orbital forming 3 sigma bond, and the last sp3 hybrid orbital contains unshared pair of electron, that is known as lone pair of electron, and here you can put the negative charge on, and that's why you can see that it has pyramidal shape. It has pyramidal shape. तो 3 important reaction intermediate कार्बोकेटायन, कार्बेनियन और फ्री रेडिकल का हम लोगों ने स्ट्रक्चर को फाइंड किया हाइब्रिडाइजेशन के बेसिस में, और एक लोन पेयर के साथ कार्बेनियन में जो बॉन्ड एंगल बनेगा that will be 109.5 डिग्री, जो sp3 का होता है उससे कम होगा, it will be 107 डिग्री. अब हम लोग कुछ और रिएक्शन इंटरमीडिएट हैं जिनके बारे में हम लोग को भी पढ़ना है, और वो है कार्बीन्स एंड नाइट्रीन्स. जैसे कार्बीन simply known as divalent species of carbon containing 1 unshared pair of electron, and structurally it can represent like this. This is 2 electron and 2 hydrogen atoms are attached with the carbon. Here you can see that the carbon acquires 6 electron, 1 unshared pair of electron and 2 shared pair of electron. So the total number of electrons around carbon is 6, which means it is electron deficient. It will be electron deficient, and all electron deficient species behaves like electrophile, and all electrophiles behaves like Lewis acid. Several objective questions can be given from this segment. So this is the carbene and it's known as methionine. Carbenes are of 2 types. The first one is singlet carbene. And singlet carbene represent like this. in which unsaid pair of electron represent like this, so that the multiplicity of the carbene is 1. Spin multiplicity is known as 2 multiply n by 2 plus 1 mu s simply represent the spin multiplicity, and if you represent like this, then there is no unsaid pair of electron, no single electron, so the value of n will be 0 and the multiplicity will be 1. Better you can write multiplicity like this: 2s plus 1, 2s plus 1. And similarly, triplet nitrene, triplet nitrene. Triplet nitrene represent like this, that is the unsaid pair of electron present in different orbital. So it is triplet nitrene, and spin multiplicity equal to 2 into n by 2. N simply represent number of unpaired electron. In this case, you can see that number of unpaired electrons are 2. So 2 into 2 by 2 plus 1, which means 3. सो कार्बीन के बारे में हम लोगों ने पढ़ लिया. कार्बीन क्या है? डाइवेलेंट स्पीसीज ऑफ कार्बन कंटेनिंग one unsaid pair of electron, and the first carbene is methylene, classified as singlet and triplet. Singlet and triplet carbene. Singlet and triplet carbene. Now we want to draw the structure of carbenes, both singlet and triplet. This is singlet carbene. The hybrid orbital will be bond pair plus lone pair. How many bonds there? 2. Lone pair 1, 3. It means it will have sp2 hybrid orbital. And the planar structure, out of 3 sp2, 2 are forming 2 sigma bond, and the third sp2 hybrid orbital contains unsaid pair of electron and one empty 2pz orbital. One empty 2pz orbital. So this is the structure of singlet carbene, distorted trigonal planar, because there is a one lone pair of electrons. Similarly, if you want to find out the structure of triplet carbene, whose multiplicity is 3, you can represent like this. And again, the hybridization, bond pair plus lone pair. How many bonds are there? 2 bonds. And there is no lone pair. Both the electrons are singly located, so lone pair will be 0 and hybrid orbital sp. sp means simply linear structure, so the carbon bonded with the 2 hydrogen atom through sigma bond, forming by 2 sp hybrid orbital, and the rest of the orbital of carbon, that is 2py and 2pz, which are not taking part in the hybridization, containing one single electron each of this orbital. So it has linear structure with the bond angle of 180 degree. So in this session, we have discussed about how to find out the hybrid orbital or hybridization of an organic molecule containing multiple bond, and also we have discussed about how to find out the structure and shape as well as the hybridization of different types of reaction intermediate. In this class we have discussed about four types of reaction intermediate, which are free radical, carbocation, carbanion, and carbenes, and two more reaction intermediates are remaining, which are nitrene and arine or benzene, that will be discussed in our next class. So continue watching to build your concept. Thank you for watching.